We were approached on this current project at the National World War I Museum and Memorial by Gold Evans. The project scope started with the mechanical room because they were bringing in a very large painting, so they had some floor work and just structural modifications to do to the building. Laser scanning was key in some of that redesign. Going forward, we've been working with our clients there. They are wanting us to do the exterior. We're going to tie it in with the mechanical stands that we've done previously.
There's no existing drawings or plans for that. It's absolutely jaw-dropping. I mean, it's amazing, but there's nothing to document it. There's pictures that have been taken, but there's nothing that can be gone into and measured. Even though it's relatively Spartan, there is some architectural flourish to it. So if you were trying to measure any of that, like the flutes and the column, erect scaffolding, boom crane, we use the Faro 330, and we have the HDR 330. We just have this amazing range, 330 meters, 1/8 inch accuracy, so 1,000 feet or so. When we have a structure like this, we're able to stand back and be getting great data from the top of that structure that you just couldn't get with most other scanners.
For local projects, we like to go out to the site. We'll literally walk it down, we'll look at the space, then we'll put them into a software called Bluebeam that we use on our laptop and also tablet. We'll plan the shots out, and then when I go out, I'll take the targets, and then once everything's ready to go, we'll start the scanner, and then we'll use those pre-planned scan location shots, and we'll move along, and then as we mark the scans, I'll mark it into Bluebeam on the tablet, and it helps us keep track of it. The other advantage to doing that is when we take the scans back to our designers, they know exactly where the scan locations are.
Once the scanning is complete, it's simple SD card exchange from the scanner to the registration, and Lacey will pick up, start the registration process, and then begin the modeling.
The registration process ties all the scans together in the correct location and then exports one file to be used. We use Scene to register our scans. We pull the scans in Scene, do cloud-to-cloud registration and target-based registration in Scene, and then we will create different file exports from Scene and pull that into our 3D modeling programs. We use Revit mostly for 3D modeling. We will do a recaps export from Scene. From Scene, we go to Autodesk Recap, and then we pull the recap file into Revit. That's kind of in the background of our model, and then we can see the point cloud, the recap point cloud in Revit, and then model on top of it.
The first scans they saw were the ones that we'd done in the mechanical room. What we presented to them was a fly through the scans, and they really thought it was kind of like grainy camera footage. We had just walked through the space with a camera. And then we explained that no, that was actually the laser scan, and that everything they were seeing were literally millions of points that were all plus or minus an 1/8 inch accurate.
The product really sells itself with the accuracy, the high resolution of data, and then our timetable.
For the difference in data that's collected versus a couple of people going out and getting field measurements, it's hard to explain the difference. I'm such a huge fan of the technology, it's hard to speak about it without just using superlatives. It just is such a benefit to the entire project team.